The Green River Formation in Wyoming is a vast fossil bed. It is a treasure trove of information about prehistoric life. In 2003, scientists made an astonishing discovery there. They found the fossilized remains of an ancient bat, later named. This wasn't just any bat fossil, it was a 52-million-year-old relic, pushing the fossil record of bats back by millions of years. This discovery sent ripples of excitement through the scientific community. It was not merely another extinct creature, it held the key to understanding a pivotal moment in bat evolution. Here was a creature frozen in time, right at the cusp of a major evolutionary leap. Its unique anatomy promised to unlock the secrets of how bats took to the skies. The discovery of in the Green River Formation was a momentous occasion. It provided paleontologists with an unprecedented glimpse into the early evolution of bats. This ancient bat became a window into a long-gone world. It allowed scientists to piece together the story of how these remarkable creatures evolved. Why, despite its age, possessed fully developed wings. These wings were a marvel of early evolution, showcasing the intricate design that nature had begun to experiment with. The fossilized remains give us a glimpse into a world long past, where creatures were just beginning to take to the skies. These were not the wings of a modern bat, however. They were a precursor, a stepping stone in the evolutionary journey that would eventually lead to the bats we know today. The differences are subtle yet significant, highlighting the gradual changes that occurred over millions of years. They were more primitive, reflecting a time when bats were still experimenting with flight. The structure of these wings suggests a creature that was not yet fully adapted to the demands of sustained flight, but was well on its way. The most striking feature of this ancient bat was its clawed fingers. These claws were not just for show, they played a crucial role in the bat's daily life. Was its clawed fingers. Unlike modern bats, which have only one or two claws, this primitive flyer had 5 distinct claws on each hand. Unlike modern bats, which have only one or two claws, this ancient bat had 5 distinct claws on each hand. These claws were likely used for climbing and grasping, giving the bat a significant advantage in its environment. Had 5 distinct claws on each hand. Imagine a creature taking to the skies, its clawed fingers outstretched, grasping at the air. These claws, along with other skeletal features, painted a clear picture of a creature that was an adept climber. Imagine a creature taking to the skies, its clawed fingers outstretched, grasping at the air. These claws, along with other skeletal features, painted a clear picture of a creature that was an adept climber. Its strong limbs and sharp claws allowed it to scramble up trees and cliffs with ease. These claws, along with other skeletal features, painted a clear picture. This ancient bat was an adept climber. Its strong limbs and sharp claws allowed it to scramble up trees and cliffs with ease. Was an adept climber. This ability was crucial in its early evolution, providing a safe haven from predators and a vantage point for foraging. Its strong limbs and sharp claws allowed it to scramble up trees and cliffs with ease. This ability was crucial in its early evolution, providing a safe haven from predators and a vantage point for foraging. The bat's environment was likely filled with dangers, and being able to climb and find refuge in high places would have been a significant survival advantage. This ability was crucial in its early evolution, providing a safe haven from predators and a vantage point for foraging. The wings of this ancient bat were broad and expansive, supported by elongated fingers, much like those of modern bats. The wings of this ancient bat were broad and expansive. They were supported by elongated fingers, much like those of modern bats. This wing structure would have allowed for a greater surface area, aiding in flight and maneuverability. Were broad and expansive. They were supported by elongated fingers, much like those of modern bats. They were supported by elongated fingers, much like those of modern bats. The skeletal structure of this ancient bat revealed another intriguing detail. This ancient bat had relatively short hind limbs, revealed another intriguing detail. This ancient bat had relatively short hind limbs. This feature, in stark contrast to its long fingers and robust chest muscles, suggested a unique mode of locomotion. It was likely a clumsy walker on the ground. It compensated for this by being an agile climber and glider. This combination of traits made it a versatile and adaptable creature, capable of thriving in a variety of environments. One of the most intriguing aspects of prehistoric bats is what they lacked: the ability to echolocate. Unlike their modern descendants, these ancient creatures navigated their world without the sophisticated sonar system we associate with bats today. Modern bats navigate and hunt using echolocation, a remarkable biological sonar that allows them to thrive in the dark. They emit high-pitched sounds and use the returning echoes to create a mental map of their surroundings, pinpointing prey with astonishing accuracy. However, the structure of these prehistoric bats' inner ears suggests that they couldn't echolocate. This anatomical detail has significant implications for our understanding of bat evolution. The absence of echolocation in these early bats suggests that powered flight evolved before echolocation in the bat lineage. This finding challenges the long-held assumption that echolocation was a prerequisite for the evolution of bat flight. It seems that the ancestors of bats first took to the skies, relying on other senses to navigate their environment. They developed sophisticated echolocation abilities later in their evolutionary history. This discovery has opened up new avenues of research into the sensory capabilities of early bats. Scientists are now exploring how these ancient creatures might have used other senses to survive and thrive. The absence of echolocation in these early bats does not mean they were completely devoid of sensory adaptations. In fact, their large eyes suggest that they relied heavily on vision. It's possible that these prehistoric bats were primarily active during the day, using their keen eyesight to navigate and hunt. This is in stark contrast to most modern bats, which are nocturnal and rely on echolocation to find their way in the dark. Researchers are now delving deeper into the evolutionary timeline to understand when and how echolocation emerged in bats. This ongoing research is shedding light on the complex evolutionary pathways that have shaped the sensory world of bats. The study of these ancient bats continues to reveal fascinating insights into the evolution of sensory systems. By examining the fossil record and modern bat species, scientists are piecing together the story of how bats became the masters of the night sky. The large eyes of these prehistoric bats indicate a reliance on vision, suggesting a diurnal lifestyle. This adaptation would have allowed them to exploit different ecological niches compared to their nocturnal descendants. As we continue to uncover more about these ancient creatures, we gain a deeper appreciation for the diversity and adaptability of bats throughout their evolutionary history. The story of bat evolution is a testament to the incredible ways in which life on Earth can adapt and thrive in a variety of environments. From the daylight hunters of the past to the nocturnal navigators of today, bats have truly mastered the art of survival. Section 4. Whispers from the Green River Formation. The Green River Formation, where was discovered, is a goldmine of prehistoric information. This vast fossil bed spans across Wyoming, Utah, and Colorado. It preserves an incredibly diverse ecosystem that existed over 50 million years ago. The fine-grained sediments of the Green River Formation are renowned for their exceptional preservation of fossils. They often preserve delicate structures, such as feathers and skin. The fossil, remarkably well preserved, provided scientists with a wealth of information. The skeleton was nearly complete. This allowed paleontologists to reconstruct the animal's anatomy in detail. The presence of soft tissues, such as wing membranes and hair, offered further insights into its appearance and lifestyle. The Green River Formation's significance extends beyond the discovery of. It has yielded a stunning array of fossils, including fish, insects, plants, and other mammals. These fossils provide a comprehensive picture of a long-vanished world. They offer clues about the climate, ecology, and evolution of life during the Eocene epoch. Section 5. Gliding through the Eocene sky. Imagine the world 52 million years ago during the Eocene epoch. The planet was a much warmer place. Lush forests covered vast swaths of land. The Green River Formation was a subtropical paradise. It teemed with life both in its freshwater lakes and the surrounding forests. This is the world where first took to the skies, shared its arboreal habitat with a menagerie of creatures. Early primates, distant relatives of monkeys and humans, clambered through the trees. Giant birds, some flightless, others soaring overhead, dominated the skies. Reptiles, including crocodiles and turtles, thrived in the warm waters. Insects, much larger than their modern counterparts, buzzed through the air. With its primitive wings and clawed fingers, was not capable of sustained, powered flight like modern bats. Instead, it likely employed a combination of gliding and flapping. It would have launched itself from treetops, gliding gracefully through the air. Then it would use its wings to flap short distances. Section 6. The missing link in bat evolution. The discovery of this remarkable fossil was a watershed moment in our understanding of bat evolution. It wasn't just another addition to the fossil record, it was a key piece of the puzzle that had been missing for so long. This fossil bridged a critical gap in the fossil record, providing a clearer picture of how bats evolved. It provided invaluable insights into the transition of bats from terrestrial to aerial mammals, a transformation that has fascinated scientists for decades. Before this discovery, there was a chasm in our knowledge. We had fossils of ancient terrestrial mammals that roamed the Earth millions of years ago. These fossils told us about the early ancestors of bats, but they didn't explain how these creatures took to the skies. We also had fossils of fully fledged bats, with their distinctive wings and echolocation abilities. But the evolutionary steps connecting these two groups remain shrouded in mystery, leaving a significant gap in our understanding. This newly discovered fossil, with its intriguing blend of primitive and advanced features, emerged as the missing link we had been searching for. Its clawed fingers and robust limbs pointed to its tree-climbing ancestry, suggesting that it was well adapted to life in the trees. At the same time, its fully developed wings and elongated fingers clearly marked it as a bat, capable of sustained flight. This unique combination of features provided compelling evidence that bats evolved from small, tree-dwelling mammals that first developed the ability to glide. Over time, these gliding mammals gradually evolved powered flight, leading to the bats we know today. This gradual evolution from gliding to powered flight is a testament to the incredible adaptability and resilience of these creatures. The discovery of this fossil underscored the incredible power of the fossil record. It revealed the intricate steps involved in one of the most remarkable evolutionary transitions in history, shedding light on a process that had long been a mystery. This discovery highlighted the importance of continued exploration and discovery in the field of paleontology. Each new find has the potential to reshape our understanding of the natural world and the creatures that inhabit it. It reminded us that the natural world still holds countless secrets waiting to be unearthed. The story of this fossil is a testament to the enduring fascination with our planet's evolutionary past. As we continue to explore and discover, we can look forward to uncovering more of these incredible stories, each one adding to our understanding of the rich tapestry of life on Earth. The journey of discovery is never-ending, and each step brings us closer to understanding the complex and beautiful history of life on our planet.